on Monday. So we were discussing conveyor models, and this is a transition to what we discussed in terms of material handling systems. And the idea is to show you how you can design these systems for your facility. So I posted these slides yesterday. This is a continuation. This is part 2 of the lecture we started on Monday. So on Monday we cover the first bullet in blue here, conveyor loop with deterministic loading and unloading sequences. And we discussed a problem and example for such type of setting. Today we are also going to cover the conveyor loop with Poisson arrivals, meaning that you're going to have some uncertainty in terms of the units that you're going to be putting into your conveyor. So going back to the example, here's the description in terms of how you can determine the capacity of each carrier for your conveyor. And we are having different parameters here, including the number of stations, which is denoted by S, around the conveyor. And also K is the number of carriers for the conveyor. And we are assuming that are equally spaced around the conveyor. And the passage of a carrier by a workstation establishes the increment time used to define the material loading and unloading sequences. So this is the type of system that we are trying to design. We're going to have a conveyor. Those dots represents the carriers. So in this case, we have multiple. And the circles around the conveyor are the stations. We also discussed the details, but going back, station 1 is used as a reference point in defining the time. So carrier N becomes carrier N plus K immediately after passing station 1, and that's what we observed when we went over the carrier number 9. We have another carrier. It's just going over that number, N plus 1. That will be the last carrier passing through the station that we are using as a reference point. And the amount of material or number of items loaded on carrier N at its last station is given by this parameter, Fi of N. So we were looking for ways to define F, or actually F, if given most of the time. What we were trying to decide or find out is the value of H, which is the amount of material carried by the carrier N immediately after passing station I. So here's some more information about the methodology. So we needed to be sure that the requirement is that all material loaded in the conveyor must be unloaded so we can have a steady state. And that's what this is representing. So at the end, when you sum the number of items that are loaded and unloaded, you should have 0, which means that you have a conveyor that is balanced. And the first step in solving this type of problem, again, what we're trying to do is to find what's the right capacity for my carriers, depending on the number of items that are loading and unloading every period. So we need to find the value of F. So for each station, or actually for each period, we're going to sum the values of F for each station and for each period. And also we needed to compute some other parameters to be sure that we can apply the methodology. And here are the equations that we're using to find out what were those values of H. So these are recursive actions that we are trying to decide. So we are solving this problem using these recursive equations. So the first one is to determine the value of H1, which is the station that you are using as your reference point. And then any other station you can find using this equation. So any Hi plus I, or plus 1, I'm sorry, can be found using the results that you find for H1 which is going to be this part of the equation minus the values of f. And then finally, in order to find the number or the specific capacity for your carriers, you need to find the value of z, and that z is going to give you the value of hi. And from those values, then you're going to decide which one is the maximum, and that's going to be your solution. That's going to give you the maximum capacity for your carriers. So if you printed or if you saw the slides for today, what I decided to do was to give you the actual numbers, the solution of the problem that we discussed on Monday, so you can use that as a reference for doing the lab. So here's the solution for our problem. We have a conveyor with only two stations, one that performs loading and one that performs unloading. We have a conveyor moving around the stations, and we have 9 carriers, so each dot represents different carrier. They are equally spaced, and we have a period of 7, which means that we're going to have 7 values for F1 and F2. F1 represents the number of units that are going to be loaded to each one of those cars. F2 represents the number of units that are going to be unloaded. So following the steps, the first thing we did was to find the value of f. So these are our f values. So for each period, we're going to sum the value of f1 plus f2. So 1 plus 0 is 1, 1 plus 0 is 1, and so on, up till you get this point, which is 1 plus minus 5 is minus 4. So those are the values for f. And then we do the check to see if we can apply this methodology for the values that we have, for the parameters we have for our conveyor. So we check the value of k over p is not an integer, r over p is a proper fraction, and p is equal to 7, which is a prime number. And this is again coming from this. And if you are not familiar with the mod operator, I provided an example here and I explained what that means in class, which is basically finding the remainder of the division between two numbers. Yes, sir.
So if one of those conditions isn't met, what would be your first action?
Yes, if that's not satisfied, then you cannot apply this method. Okay? This third condition is not necessary, is something that will make the solution easier to obtain. But the first two, yes, they need to be satisfied. For the purpose of the exam and also for the purpose of the homework, I'm going to give you some problems that are going to satisfy all these conditions. Okay, but that's something that you need to know. If you go to industry, if you go to practice, then this is one of the methodologies that you have, but you need to check that the system satisfies the conditions. Okay, so after that, then we decided to apply the steps. So we started by assigning H1 start 1 value of 0, because we need to start with the value. So we assume that the first car will have the 0 entities loaded to it after passing the first station. And then using that and the value of R, we can start defining the values for the other time periods in our design. So we start with H1, 0. So the value of R is 2. So basically what you do is you add 2 to the value of the first carrier that you're considering, and that's why you have 3, which is 1 plus 2 is 3. And then you continue that process by adding 2 to your next car, adding 2 to the next car that you're going to consider, until you get to the point in which you have to start repeating the process because you know that the period is already completed. So you have 7 units in your period. So once you get to 7, you are able to use those numbers, but once you go to H1 of 9, then you know that you're going to be repeating the process or the period for the loading and unloading. So that's why H1 of 2 is equal to H1 of 9. And something that was a question that we had in class last Monday was why are we getting some negative values and for some of these H1 stars? And by looking at this solution right now, we are not finding the values of H1 at this point. These are intermediate computations that we are going to perform in order to achieve the solution, which are the actual values for H1 and H2. So if you see these stars values, this means that the are intermediate computations that will allow us to get to the final solution, which is here. Okay, so here there's no star. These are the values for H1 and H2 for our problem. So once you determine all the values for H1 star for all the carriers from 1 to 9, then you have to determine the values of H2, and we observed that was equal to this. So you have to use the value of H1 and subtract the values of Fi. So that's what we did in this step. We are subtracting values of F to H1. H1 star is here, F of N is here, so we obtain the values of H2 star. Then we find the minimum of all these values, consider H1 star and H2 star, and that value is minus Q. And finally, we go back here. To find the desired solution, we need to subtract the value of Z to all the values of H1 star and H2 star, which is what we performed in this step. And once you got those numbers, then the maximum is going to give you the maximum capacity that you can have for your cars. So again, I'm going kind of quick through the solution of this problem because we described and we solved this problem in class on Monday. The reason I'm going over the details is because now you're going to have a problem to work in groups as a lab. And again, the only difference between this problem and the one we solved in class is now you're going to have, instead of 9 cars, you're going to have 10. And I want you to see what would happen when you increase the number of cars. So please let me know who are you going to be working with. Something that you can try to do, I think would be a good strategy, is you can try to put this solution into Excel. That will help you see how the solution is working. And then once you have the problem solved in Excel, it's just a matter of changing the number of cars. And you will obtain the solution. So that's one strategy that you can follow, or you can just try to solve the problem by hand. It's up to you. But I will essentially up to. So I can tell you, the first thing that you're going to notice is going to change is the value of R, because now you have a different number of carriers. So R is K plus P. So P is going to be the same value, but K will go from 9 to 10. So R is going to be different, and that's what's going to change the way the solution is done. So now instead of going, when you're going to this point, you have n minus r, instead of this being 3, this is now 4. So you will be finding the values of h1. You can assume h1 is going to be 0, but when you go to this point, this is going to be different value. Yes, sir. For our example, yes, yes. I mean, it's anything that, yes. So you have to perform the values for R, and R equals H plus B. So whatever that number is. Okay.
The initial point for the H, we assume that's 0.